All right, this problem has horizontal asymptotes on it, which just means that the graph is going to get super duper close to getting up to a y value of 2 and super duper close to getting down to a y value of negative 3, but they're not actually going to get there. It'll eventually get to like 1.99999 and negative 2.99999, but it's never going to get to negative 3. So keep that in mind when you're deciding whether or not to include your endpoints on your range. But we do have a continuous graph. You could graph this entire thing without picking up your pencil. There's no scattered points anywhere. So we should be able to write the domain as using an inequality. And well, frankly, the domain, this thing will go forever to the left and forever to the right, as well as hit all the x values in between. So our domain's pretty simple here. It's just all real numbers. And I'll use that double bar R to represent real numbers. As an interval, all real numbers would be everything from negative infinity to positive infinity. And of course, we use parentheses on the infinities because infinities are never included. For the range, instead of looking left to right, we look low to high. And the lowest y value that's relevant to this graph is the negative 3. Now, we never actually get to negative 3, but we get infinitely close to it. So our range starts at negative 3, but doesn't include negative 3. So I'm going to leave that as a less than, not a less than equal to sign, because the asymptote never actually gets touched. And every y value between the asymptotes is accounted for somewhere on the graph, so all the between stuff is there. And we top out at a height of 2 without ever actually getting to the 2, because again, there's an asymptote there. And then as an interval, we would have everything from negative 3 to positive 2. Neither endpoint would be included. That's why we use the parentheses, just like how we do not have equal to signs in our inequality.